Absorption spectrum. Now, the name itself tells that something is being absorbed, right? But then last video we saw emission spectrum, wherein things were being emitted and we were watching it. Watching it meaning we were observing the particular radiation, right? Here, absorption spectrum. So, absorption spectrum is where the radiation, or you can say the energy, is being absorbed by a particular material. Okay, now I'm specifying on the word material and not on being an element, because it need not be an element in the periodic table. It could be combination of materials also, combination of elements. Okay, so when we say combination of elements, that means it could be solid, liquid, or it could be a gaseous matter. Okay, any three of them, any three states of matter. Alright, so bottom line, absorption spectrum is you have a source, you pass it through some material, and then the material absorbs certain radiations. Okay, then we watch that. This is what we call as absorption spectrum. Okay, now let's see how this absorption spectrum is, what it is, how we measure it, all these things. Okay, now the general thing about this absorption spectrum is we need to have a source. Okay, a source of some emission, some emission spectrum is there, or you can say some source is emitting radiation. We pass that radiation through a material. Now it could be a solid, or it could be a liquid, or it could be a gas. Any three states of matter. As the radiation passes through that particular material, now certain wavelength or certain wavelengths, it could be multiple or it could be a single wavelength. That material will absorb the wavelength. And as it absorbs the wavelength, then what we do when we see that particular spectrum through a telescope and prism and everything, we see dark bands in between or dark lines in between that continuous spectrum. This is what we call as absorption spectrum. Now here we have two types of absorption spectra. One is absorption line spectrum, another one is absorption band spectrum. Very similar to line spectrum and band spectrum itself. So in absorption line spectrum, we have discrete lines. In the sense, we have a continuous band, alright? In between, we will see dark lines. Okay, or you can say black color band, black color lines you can see in between those continuous spectrum. Alright, then we have absorption band spectrum. In absorption band spectrum, we'll see, so you have a continuous spectrum. In that, in between, we will see band of black color. Alright, or you can say dark bands will be there. Starts from sharp and then gradually it fades out. The intensity gradually decreases. These are two types of absorption spectrum. Now we'll see a small illustration of how this absorption spectrum will be there. Okay, and how do we observe it? Now, see, consider this image. Now what we get, see, we have an electric arc, right? So this electric arc, you can say, or an arc lamp. So this produces continuous emission spectrum. Alright, this is made to pass through a small slit, and then it is made to pass through sodium vapor. Then we have a collimator, a prism, and a telescope, isn't it? Now you can see how the ray of light is moving. But then when we see the spectrum of this, we will see two dark lines in the continuous spectrum. Okay, two dark lines. That too we'll see it in the yellow region, yellow colored region. Alright, something like this. See, you will see two dark lines, correct? Now why that happens? You see, you have continuous spectrum. Energy is being emitted in all wavelengths. When that particular energy passes through the sodium vapor, the sodium atom, it absorbs the energy. Okay, when it absorbs energy, that part of the band becomes dark. because energy is being absorbed, isn't it? And since it is absorbed in that particular band or particular wavelength, when you see the absorption spectrum, or you can say when you see the spectrum, you will see two dark bands. Okay, two dark bands. Now, see, this is for absorption line spectrum. Instead of sodium vapor, suppose if I keep some other molecule, then we will get absorption band spectrum. Okay, so very easy to identify. Line is for atom, band is for molecule. Okay, always keep this in mind. Again, I'll repeat this. I'm stressing this because it's important. Whenever we have line, it is for atom because it is discrete. Whenever we have band, it is for molecule because it is a little bit continuous. I'm not saying it is completely continuous, but it's partial. Okay. Now, see, we saw that this is a absorption line spectrum, correct? An absorption band spectrum looks something like this. Clear? So what did we do in this? It's very simple. We saw water absorption spectrum, correct? So what you have is, you have a source and you have a material in between. Then we have the observing part. The energy from the source passes through the material, and particular energy or particular energies, that frequency or the wavelength is absorbed. And then when we look at through the spectrum, we will see either dark lines or dark bands. Alright. Now, where do we use this? Is that in almost all types of astronomical observations. See, you must have seen that, okay, this particular star, which is thousands of light years away, it has so much of helium, so much of oxygen. Now, how do we figure out what material the star has? Because of the absorption spectrum. Okay, so we look through the telescope, we'll see the light, we will see what lines are being absorbed. Okay, so if this particular line is dark in the spectrum, that means this energy is absorbed. So this atom has to be present in the star. This is how we use this absorption spectrum. Clear? So we saw this emission spectra, we saw absorption spectra. Any atom, whenever it is excited, as it comes down, so it emits. Either we can observe the emission spectrum and learn about the atom, or you can say the orbital structure, or we can study the absorption spectrum and then we can study about the matter.